Hello, guys. How are you?
Professor.
Good morning.
How you guys doing?
I'm all right.
Professor.
Yes, Miss Jamara. How are you?
um, I sent you an email with the missing assignments this morning. So I just wanted to, I sent it like 10 minutes ago.
Okay, I
So,
will check it after we finish.
okay, I was just letting you know because I told you I was going to send it that day, but I ended up sending it this morning. So,
No problem.
all right.
I will check it as soon as we finish. Let me check, see who and who is here. Oh, you are here. All right, all right, all right, all right. So today, actually this week, no, this is the Thanksgiving week. Am I right?
Yeah, that's on Thursday.
Yeah, so we're not gonna have a class on Wednesday. And of course, Thanksgiving holidays begins on Thursday. So that means we're gonna see again on Monday after today. So let me show you what you have this week. This is my announcement for week 15. Chapter 11 of your textbook, or you can just read the PowerPoint. I have it already uploaded for you in the module. Then the project, continue the project is due on the 6th of December. That's the only assignment I can think of this week. This is a holiday week, so I don't want to mess up your holiday since you already have your project to work on. Okay. Um, then of course, you can get access to the project by going to the models and scrolling down to the week. This model is for week 14 and week 15. And you can see the project right here. The presentation for today and the spreadsheet, you can see both of them here. You can download them, okay? Because the next test or classwork, I'm going to pick one question from any of the remaining this presentation and the next one, okay? So today we'll be talking about, actually we have discussed this at the beginning of the semester. It's called the supply chain management. But this one, we'll not be doing going through the pros and cons. Well, pros and cons might be included, but we are focusing today on the more on the supply chain management analytics. Okay. So because we have, like I said, we have introduced it at the beginning of the semester, what supply chain is, how it works. Now, but let me just refresh your memory. Supply chain simply means those interconnected network of individuals, individuals, businesses, resources, activities, and even technology. These things are involved in the production, handling, and distribution of goods and services, from the raw material stage to the final delivery to the customer. So we call them a supply chain because they are all interconnected. So, the story of supply chain, I think I've explained this before. It became very popular during the Industrial Revolution. Not that we don't have supply chain before the Industrial Revolution, we do, but they became more popular during the Industrial Revolution of the 18th century when mechanization transformed industries and also enabled mass production and distribution. Now, when we talk about supply chain management, on the other hand, okay, this is an example. I use Apple. It's a good example. I use Apple supply chain, which Apple is, of course, an Apple computer and the Apple iPhone. They operate one of the most efficient, just like Amazon, one of the most efficient and complex supply chain in the world. And the supply chain begin from sourcing the raw material, like the rare earth metals from the mines in China. China has a monopoly of the rare earth metal. When I say rare earth metal, this rare earth, you see it in every electronic component today. That's smart TV, electric vehicles, smartphone, all kind of electrical components that are rare earth metal. and China has monopoly of that. Some countries have it. I'm hearing that they have found a large quantity in Ukraine, but I haven't confirmed it yet. So anyway, so from sourcing the raw material like the rare earth metal from mines in Congo, in China and Congo, to assembling the product in facilities in China and some places like Cambodia and other Asian countries. Then through this complex interconnected supply chain, Apple ensure that a seamless integration of design, manufacturing, and logistics. If I may use the smartphone as an example, if you look at that smartphone that you have, the components of that make it up, what it went through, it represents a lot of countries and supply chain in this smartphone. It traveled an estimated 20,000 miles through the various supply chain processes before they reach to us as a customer. Now, when it comes to supply chain management, we mean the idea or the concept or the practice or the strategy involves a kind of a strategic coordination of the activities and resources in the supply chain. The goal is to maximize efficiency, reduce cost, and enhance customer satisfaction. Now, Walmart, and of course, one of the reasons why Walmart have cheap products is because they have, I would say, mastered supply chain management. Amazon is the king of e-commerce today because they have also mastered the supply chain management strategy. They have a supply chain management strategy that is really a good standard. Okay. So now, going to what we have today, which is the supply chain management analytics. So there are many techniques we can use to manage supply chains or evaluate the supply chain. Okay. Basically, what we do with them is to evaluate the performance of the supply chain within the company, as well as the supply chain partners. So those techniques build and evaluate the performance of the supply chains. And we'll be looking at 5 of them. But today we'll be focusing on one, which is the decision tree. Okay. Well, 5 of them, we have decision tree, we have measuring bullwhip effect, factor weighing approach, transportation mode analysis, and the warehouse storage. Let's start with decision tree. But before that, I want to say this. Now, and this has to do with evaluating disaster risk in the supply chain. Now, what disrupts the supply chain is we call it disasters. I will call it disaster. So they can take many forms. Things like pandemic, of course, we all know how COVID-19 led to many close down and affected the supply chain at that time. Almost 2 years lockdown we have. Then tornadoes, fires, hurricanes. Some of them will come, they may disrupt only one sector, but some will disrupt the entire sector. Okay. The best way to put it is that this disaster affect different sectors differently. So hurricane, typhoon, tsunami, earthquakes, terrorism, all these things can affect our supply chain. So a company needs to, or I will say an operation manager, I have to use multiple suppliers, or make sure that the company they run use multiple suppliers to mitigate the risk of total supply disruption. But so even sometimes that multiple supplier may not even work. But you do the best you can. Now, let's look at the decision tree. Now, a decision tree that we use in the supply chain evaluation, it can help us to make important decisions about the number of suppliers we have, etc. Now, we will use the following notation for a given supply cycle, we look at the S represent the probability of a super event that would disrupt all suppliers simultaneously. So the probability that it will happen, U means the probability that a unique event that will disrupt only one supplier. Then L represents the financial loss that is incurred in a supply chain if all the suppliers were disrupted. Then C represents the marginal cost of managing the supplier. So let us, a few more things with regard to computing the probability that a supplier disruption will occur or will not occur using the decision tree approach. Now, all suppliers will be disrupted simultaneously if a super event occurs or a super event does not occur, but a unique event occurs for all the suppliers. COVID-19 pandemic is a good example. Many suppliers were affected. But assume that the probabilities are all independent of each other. Then, if we assume that, we can calculate the probability that all n suppliers, where n small n represent the number of suppliers, will be disrupted simultaneously. So this is the formula we use to calculate that probability. Pn equals s plus 1 minus s times u to the power n, where, of course, you know already that s represents the probability of the super event that will disrupt all suppliers simultaneously. And u is the probability of a unique event that will disrupt only one supplier. So we have the formula here. Pn equals s plus 1 minus s times u to the power n. Pn is the probability of that us and suppliers will become disrupted. Now, you remember from the decision tree, we use it to present the manager's alternatives. There are some symbols that we use there that you need to remember. We did this already when we are doing decision-making models. The box symbol represents decision nodes from which one of the several alternatives may be selected. And this circle type of symbol is represent these different states of nature nodes, out of which one state of nature will occur. Now, let's try an example here. It said, this company, Shanghai Manufacturing, okay, Shanghai Manufacturing Corporation. Now, the president of this corporation, Xiaxian, I can't pronounce the name, but sorry about that. Xiaxian Geng is the president of the Shanghai Manufacturing. So anyway, he wants to create a portfolio of suppliers for the motors used in her company's products that would present a reasonable balance between the cost and risk. While she knows that a single supplier approach has many potential benefits with respect to quality management and just-in-time production, she also worried about the risk of fires, natural disasters, or other catastrophes and the supplier plant disrupting her firm's performance. So based on the historical data and climate and geological forecast, Xiaxian estimates that the probability of a super event that will negatively impact all suppliers simultaneously is 0.5%, which is, of course, 0.5% means 0.005 when you change it to decimal during the supply cycle. Now, she also further estimated that the unique event risk for any of the potential supplier will be 4%, which is 0.04 when you change it to decimal. Now, the question now says, assuming that the marginal cost of managing the additional supplier is 10,000, and that the financial loss incurred if a disaster caused all suppliers to be down simultaneously is $10 million. How many suppliers should Xiaxian use assume that up to 3 nearly identical suppliers are available. B, suppose that the probability of a super event increases. Suppose that it increases to 50%. How many suppliers will she need? Okay, let us start by, if you I would say explanations. Now, so we're going to use decision tree for this. We need the basic data, the choice of decisions, the probabilities, and the payoffs. Okay. Now we are given all this information in the question, and they can see this decision tree right here. We'll come to that in a minute. Okay. Now, so now we the branch of the decision tree. Each of these branch represents 3 decisions, because now you say that there are 3 suppliers available. So, and we have to assign the probabilities using the formula that I just explained before. Now, I want to let us see. First thing now is to calculate the probability of that all the suppliers will be disrupted. So I'm going to put all this information they give us here. The probability, 5% of super events happening and 4% of unique events, and the additional cost of supply of 10,000, and then the financial loss that we incur if a disaster happens. I'm going to put them in Excel, and then we now apply the formula to solve it. After calculating the probability of the total disruption given the 3 suppliers, and we will also calculate the expected monetary value, then we can be able to answer that question of how many suppliers will Xiaxian use. So having all this information, I put them in Excel. Let me show you where I put them right here in Excel, and then we can do the calculations. So you can see that, okay. Let's see. Now we have this, the probability of super event, probability of unique event, marginal cost of hiring a supplier, and the financial loss if a super event occurs. I'm gonna make these 2 to be dollars. See, so we can Now let's calculate the probability of disruption, total disruption. Okay. Now we are going to be using this formula to calculate it. Okay. Now we have total disruption probabilities, PN. For one supplier, you're going to be, remember, is S plus 1 minus S times U to the power N, where N represents the number of suppliers. For example, for one supplier, N is 1. So we're going to put equals S, which is super event probability, plus, okay, it says here 1 plus S, okay, which is 1 plus S. Again, it says times U to the power N times U, and our U is right here. So I'm gonna click on it, raised to the power N, and N is for is 1 because we say one supplier, so you're gonna put 1 right there. That'll give us this. See, probability of total disruption 0.0452, and you're going to see that result here as well in the presentation. See, I'll go back and show you right here. You can see 0.0448, which is the same as what we have here on the see 0.0452. Probably this might be a typo. Let's see. Let me go back to it again. Yeah, 0.0448. Probably a typo. Now, Next one is the let me double check it, make sure that it's just a typo thing. Okay. Suppose I put this in parentheses. Okay. You have type. Okay. U raised to the power 1. And then put it in parentheses. And put this in parentheses. Let's see. Yeah, type 2. Now, next will be the two suppliers. If for two suppliers, repeat the same process. S, that is N is 2. S is 0.005. Okay. Plus 1 minus S to the power. So we have 1 minus S. Okay. Times 0.04 raised to the power 2. Because now two suppliers. 0.006592. Okay. See? 0.006592. 6592. So this one is a typo, probably, obviously. Now, next is for three suppliers. We have the same thing equals S, which is the super event probability, plus 1 minus S again, okay, times for three suppliers. You got 0.04 raised to the power 3, okay, 0.00506. Again, you can see this calculated here as well. Okay. Now, we have the probabilities. Now, next thing, to be able to answer the question of how many suppliers we should Ziaxian hire, or use, given that you have three identical suppliers available. You have to calculate the expected value of loss using the formula. Even I will say expected monetary value. Well, it's the expected value of the loss. Okay, it's gonna be N times C plus Pn times L. Remember that C and L, remember that C represent the marginal cost of managing a supplier, and L represent the financial loss incurred in a supply cycle if all suppliers are disrupted. So we have calculated the probability. Now let us calculate the expected value of the loss. What it's gonna be. Again, I put information in the here. So we're gonna use all these three probabilities to calculate the expected value of loss. For one supplier, the expected value of loss now becomes one supplier is 1 times the C, and C is the marginal cost. Okay, close the parenthesis, plus Pn, that is the probability for one supplier, is this one here, times L, and L represents the financial loss if the super event occurs. Close it, and that gives us 462,000 for one supplier. And you can see it right here. And because of that typo in the other previous slide, it might be a little bit different. You see, 458,000 because of this typo here. Yeah. Okay. Now for the two suppliers, repeat the same process, equals 2 times the C, which is the marginal cost, close it, plus Pn, which is the probability for two suppliers, times L, which is the financial loss if a super event occurs. 85,920. Okay, for two suppliers. See, and you can see right here. See right here as well. Now let's try it for three suppliers. If you decide to hire three suppliers or use three suppliers, the value of loss will be equal 3 times the marginal cost, okay, of hiring the supplier plus probability for three suppliers is right here times the financial loss if the supply event occur, given that he has three suppliers. See, 80,000. So that means that this is using three suppliers will give you less uh, financial loss if the supply event occurs. So which means that the advice we shall give the lady is that they should hire they should hire three suppliers. So the answer to the question, how many suppliers should Xiaxian use, now becomes to hire three suppliers. Now you can see from this decision tree, the same calculations, the result of see the one for one supplier, expected loss, financial loss if the supply event occurred. Two suppliers is 85,920, and then three suppliers is around 640. Now look at some state of nature. If the financial supply event occurred, if there is no supply event, you can have this the outcome like I times C, like give you this result. I think I have them here in the Excel as well. For two supplier, I can see that it's right here. So if less than one per supplier fails, then you have the outcome to be 20,000. But if both fail, the loss will be almost 10 million plus. So now we have anyway, let's go back to the question. The next question asked us was to find, suppose that the probability of a supply event increases to 50%. How many suppliers will be needed now? Okay. Now, anyway, the operation manager can see from decision tree the outcome we have here. One supplier lose more money if a supply event really occurred. Two suppliers, you lose some, of course you're gonna lose if you have two suppliers, you lose 85,000. But for one supplier, you're talking about 458,000 loss. Now for three suppliers, 80,640 loss if a supply event occurred. So three suppliers is better for her. Now, but the next question was, suppose that this probability of supply event happening increases to 50%. How many suppliers we needed? Now, to answer that, since we have already done the calculations here, all we need to do is to, I'm going to move this here. I can just copy this result here. Okay, just so that I will not eliminate them completely. See, this is probability of a supply event is 0. This is part A. This is part B. Okay. So if it says if the probability of supply event occurred is 50%, then change this to 50%, and I want you to watch the outcomes here. Okay. Let me highlight it so that you can see what I mean. Give me a different color. Okay, watch the outcome here. So change this. I'm gonna change this to 50%, which is 0.5. And you can watch here, you can see that it will change. In that case, the two supplier will be better because it has lower amounts, less amount of the loss will be lesser for in spreading or if you have two suppliers. You can see right there. Okay. Now going back to the presentation. Excuse me. Going back to the presentation. Now, does anybody have a question in what I've explained so far? Guys, any question? Hello, guys.
No.
Okay. All right. I think that is where what we want to cover today. Let's lecture. Before I let you go, I want to mention a few things, which is the have to do with the implication of using this formula here. Using it is that the main first implication is that as the probability of super event increases, then the advantages of using multiple supplier diminishes. And you can see that from when I increased it to 50%. You can see that now instead of using 3 suppliers now, 2 supplier becomes better. 1 supplier is not good. 2 become better than 3. Unlike when with the probability of a super event was less, like 0.05, it was better to use 3 suppliers. But as it increases, then it means that it is no longer become popular to use larger number of suppliers. Another thing is that the lag values of the unique event as it increases. Sorry, the lag values of unique event increases the likelihood of using needing more suppliers. Now, if you don't have any question, then I will say enjoy your Thanksgiving, and I will see you guys on Monday. Okay? Hello, can you hear me?
Yes, sir. Now I
Yeah.
have personal questions.
Yeah. Okay, sir. I'm here. Who is speaking?
Joseph.
Oh, Joseph. Yes. What can I do for you?
No, I just seen that you had went through and put all the grades in and everything like that. But we had already discussed because I told you that at my job it just started peak season, so I haven't been able to call off and I've been sick. I don't know if you can still tell or if I can turn my camera on so you can see, but I can't breathe out my sinuses at the moment. Um, are we still able to submit those assignments, or are they fully closed?
Which of the assignment are you referring to?
Um, let me look right now.
No, what you're going to do is to send me an email with the assignment. Let me look at it. But it depends on attendance, your attendance score, though. But send me anyway. Let me look at it. See if there's anything I can do.
Okay.
Yeah, if every assignment in this class have a name, so we have to put the name like classwork 1. The ones they want to redo. Okay.
Yeah, I'm looking
Yeah.
at.
Send it to my email now. Yeah.
Okay, thank you.
Welcome. All right, guys. Any other question before we go? Hmm. All right. See you guys next Monday. Since this is the Thanksgiving week, we're not seeing on Wednesday. And enjoy yourself and have nice Thanksgiving.
You too.
Okay.